6.2, volumes by cross-section. Essential question, how do you represent in integral notation the volume by cross-section? All right, let's go ahead and take a look at how this is different from volume by revolution. In this solid, when we slice it, we are going to have a slice in which we can find the area of the base. What's going to happen is that this slice is always going to have the same characteristics of the base. The shape is going to maintain its same shape, maybe not the same size. And what we're going to do is we're going to find the volume by finding the area of the base and then timesing it by the height. And this is going to be a little piece of the volume, and we're going to add all of these little Riemann sums, which all represent little small pieces of volume, and add them all up. Okay, so this is volume of a solid by cross-section. We need to be able to describe the cross-section area and multiply it by its little width and add up all of those to get our exact volume. And here is our method. Important again is to find the formula for the area so that we can find the integrand, and of course we need the limits of integration. Here's an example of a square pyramid on its side, and you can see when we slice it, the cross section, its area is going to be a square, and then it has a little width, which is delta x. So this is really just a little prism, and we're going to be adding all these little prisms up together for this particular cross section. Okay, let's go ahead and do a problem. The hardest part is the start, which is to try to find the area of the base. So the volume, a little piece of volume, is equal to the area of the base times the height, and in this case it's going across the x-axis, so it's delta x. So we have right here little cylinders that are side by side together, and they have a little width right here. And that's what we're trying to find. Okay, so we know that the shape of our base is a circle, so I'm going to write pi r squared delta x. Now, what is my radius? My radius goes from the x-axis up to the curve, and that top curve is this thing right here. So I'm going to write equals pi, and I'm going to write the radius is y of the curve. In this case, this is the y of the curve, so I'm going to write equals pi times, now this should have been a delta x. I'm changing that. And this is the y of the curve will be the square root of 1 minus x squared. And this is the radius, and I have to square it. And when I do that, I am going to get 1 minus x squared delta x. Okay, now to find the volume, I'm just going to take my integrand right here, and I am going to integrate, and it says where to integrate here, from -1 to 1. And right here is an example of the area of the base, and that is shared right over here. Okay, let's go ahead and do the same problem with the cross sections are a different shape, but they're all sitting on this circle. So let's take a look at this square, and here's I've drawn a square right here, and from halfway on the side to the up is the y of the curve, and the whole side of the square has to be 2y, and then the area of the base will be the side squared. So now I'm ready to set up my volume now that I know what's going on here. So delta V is equal to the area of the base times delta x, that's going to be my height, and my base is 4 y squared. It's actually a square, delta x. And I know my y right here. Y is equal to root 1 minus x squared So I'm going to write 4 times root 1 minus x squared, quantity squared, delta x. And that's my integrand, so the volume will be equal to the integral from -1 to 1 of 4, and then I can simplify this 1 minus x squared dx. And that'll create my volume. Okay, same base, we still have this circle, but now we're going to put, our cross sections are going to be squares, but this time the square is sitting a little differently. The diagonal of the square is going across the circle. So here's what we have right here, the diagonal. Now we know that a square is, it's an isosceles triangle, right triangle, and we know this is a 45, 45, 90. So we know the sides are d divided by root 2. And when I multiply the two sides, I'm going to get, this is my formula for my the area of the base. So a little piece of volume will be the area of the base times the height. I don't need to write height, I need to write delta x. And my base is d squared over 2 times delta x. Now what's my d? My d is all the way across, but from here to here is the y coordinate. So I'm going to write 1/2, and I'm going to write for d 2y of the curve. So the y of the curve is that halfway mark up, and when I times it by 2, that'll create the whole diameter right here. And then I write d delta x. Okay, so then I can write 1/2, and then this will be 2, and the y of the curve is the same that I've had before, 1 minus x squared, quantity squared, delta x. So this is going to simplify to be, now when this squares it'll going to be a 4, so this will be 2, and when I square this it'll be 1 minus x squared delta x. So here's my integrand. My volume will be equal to the integral from -1 to 1, and here's my integrand, 2 1 minus x squared dx. Okay, same base, it's a circle, but this time I want equilateral triangles. So let's go back to geometry and take a look at what's going on. When I have an equilateral triangle, all the sides are the same, so this stands for side S. And this is in a 30, 60, 90 triangle, so I know the short leg is 1/2 S, the hypotenuse is S, so the long leg is 1/2 S times root 3. Now, to find the area of the triangle, it's 1/2 the base times the height, and this simplifies to this. So I would spend time having that memorized so that you don't have to go through this whole process again. Okay, a small piece of volume will be equal to the area of the base times delta x. In this case, it's going to be root 3 over 4 times s squared delta x. Now, the side, this is the whole side, and right now we can get y, all right? That'll be the y of the curve. So to get the whole side, you're going to have to double it. So this will be equal to root 3 over 4, and what we're going to square is, we're going to take 2y of the curve, and we're going to square it. And that'll create that whole side. So now we'll have root 3 over 4, and then this is going to be 2, and then our root 1 minus x squared, quantity squared delta x. And then when I go up here, I'll have, this will be a 4 when I square it, so we'll have root 3, and then when I square this, it'll be 1 minus x squared delta x. So that's my delta v. So volume will be equal to integral from -1 to 1, here's my integrand, root 3 times 1 minus x squared parentheses delta x. Okay, now the remaining are ones that you want to try. So go ahead and try this. Stop the screencast and see if you agree with the solution. Here's your next try it. Stop the screencast, see if you agree. Here's your next problem. Stop the screencast, see if you agree. Here's your next one. Stop the screencast, see if you agree. Here's your last one. Stop the screencast and see if you agree.